We learned 3. Yesterday we talked about, that'll be tomorrow. We didn't finish the section yesterday.
Oh, so we just gonna finish the section?
So we're picking up from yesterday, so you know it should just continue. This one is quadratic form. We got through, yesterday we got through sum of 2 cubes, difference of 2 cubes, and grouping, right? Is that it? Okay. So this one is what we're going to call quadratic form. Okay. So we talked a lot whenever we were factoring quadratics about how we factor them. And whenever we have a quadratic 2-factor, what do we do with it? Put it in the what? Well, that's to solve. But if I want to factor it, I can put it in the box. Remember? And I told you the box is nice because it always works. Yeah. Right? For any quadratic. Well, you can also factor things that are in quadratic form. And quadratic form basically means that you have...
Seems like the same thing.
This is an even exponent. The middle term... And let me think about one that's going to work. The exponent on the middle is half of the first. And the last one is a constant. This is quadratic form. So even, half, and constant. Tell me that it's in quadratic form. And if it's in quadratic form, I can factor it just like a quadratic. And I'm going to show you how. You gotta tell me when you're called up and I'll...
What's the constant?
Yeah, no variable hooked to it. Let's say, we'll just do this one and then we'll do another one. All right, so I've got x to the 4th plus 5x squared plus 6, and I'm asked to factor it, and I recognize that it's quadratic form, okay? So if this was a regular quadratic, I'm going to assume that you would go through your steps. Does it have a GCF? No. Is it a special pattern?
No.
No. Can I use the box?
Yes.
Sure, because it's quadratic form. So you set it up the same way. The first term goes in the first box.
X to the 4th.
The last term goes in the last box.
6.
Now remember the steps when we do this, whenever it was just quadratics. You multiply these two together, right?
Yeah.
I need 2 things that multiply to 6x to the 4th, but add to 5x squared.
5x squared. Oh, yeah.
Somebody said it. 3x squared and 2x squared. Do you see why? Multiply together, I add the exponents, right? And that would give me the power of 4 there. And whenever I add them, I just combine the coefficients, and that would give me the 5x squared. So that goes in the box.
Oh, you going to do nothing with the exponents with that?
I'm fixing to show you. The exponents are going to come into play whenever you start doing the GCF up and over. As I go up here, if you look at that, x to the 4th and 3x squared, what's the greatest common factor of those two?
X to the 2nd.
Good job. And what's the greatest common factor here? 2. How about over?
X squared.
And how about over again?
3.
So this factors x squared plus 2, x squared plus 3.
Oh, we done.
I am done because they're not perfect cubes. They're not perfect squares. It doesn't factor anymore. So I can't do anything else and I'm done. Does that make sense to you?
Oh, just like the other one.
Let's try one more. It's just different because it's not quadratics. Now we're talking about polynomials. What you talking about, Shami?
I hope this is that easy every time.
Well,
Man, you don't know. You didn't do the lesson yet.
oh, this is not what I want. Don't write that in yet. Sorry.
Oh, my.
I'm sorry. Oh my goodness. Y'all are a tough crowd. Here we go. I got one I want to use. 2x to the 8th plus 10x to the 5th plus 12x squared. Oh.
Oh, we gotta do the coefficients first. 2 go in the all of them, man.
Right. Y'all are exactly right. You're getting so excited. You take out the GCF. That's right. So I heard 2. That's right. What else can you take out? X squared. So let's look at what's left. What's left in the first term?
X to the 6th.
X to the 6th. What's left in the second term?
5.
And then what's left? Plus 6. What do you notice now about what's in parentheses?
That you can do it.
Why can you do it? Can you do it? Can you not do it?
You can. Because you have even
The first one's even. Yeah, that's right. Keep going, Tanner. Keep going. Yes, we have a what? Go ahead. Even exponent. Be confident.
This one is half.
The next one's half, and the last one is a constant.
What's a constant?
No variable hook to it. It's just a number by itself. All right. So since it's quadratic form, box. What goes in the first box?
X to the 6.
What goes in the last box?
6. 6x to the 6.
What multiplies to 6x to the 6th but adds to 5x to the 3rd?
2 and 3.
2 what and 3 what? 2x cubed, 3x. Oh, that's the same one. Oh my goodness. All right, up and over. GCF. X to the 3rd. GCF. Okay.
How did that even happen?
Oh, I don't know. I made the first one up off the top of my head. This one I pulled out of the book. I need to still look. Can any of the parentheses be broken down any further? No. They are positive. Well, that's okay if they were perfect cubes, but 3 and 2 aren't perfect cubes, so it can't break them down any further. Does that make sense, everybody?
Yeah.
Everybody?
Yeah.
All right. Do we need to do another quadratic form, or you think you got it? All right, then let's talk about factoring and solving, because there's a reason we do all this. When we were talking about quadratics, it was so that we could find out what x equals, and what x equals was, we talked about those were the zeros of the function. Those were where it crossed the x-axis. So we're doing the same thing here, but we're polynomials now.
This is a new lesson right here?
This is the rest of that same lesson. So, you will have something that looks like this. And it will simply say, solve for x. You absolutely will. So remember, whatever we're doing, it's always easiest. We need to make it equal 0 before we start. And I'll tell you, the easiest thing to do is to make sure the leading coefficient, which is the one with the biggest exponent, make sure that stays positive. So I'm going to put your little note. Keep the first term positive. So, Juliana said move that negative 6x to the 4th over. So that's what we're going to do. And when we move it over here, we move it by adding it. So we get 6x to the 4th minus 27x cubed, 15x squared equals 0. Now, it just said solve for x. What can I do? It equals 0. So what are you doing? What process? What are you doing? You're trying to do what?
Square.
Starts with an F. Factor it, right? Because factoring means get it into a multiplication problem, and then I can set each piece to 0. So y'all told me one thing you could do first. You said 2, take out what? X squared? 3x squared. What's left? 2 minus 9x plus 5 equals 0. Now I want to factor completely, so maybe I should put your little steps here. Now, after you make it equal 0, I want to factor completely. Am I done factoring? No. What do I need to do? Put it in a box. What? You aggravate. I'm just picking.
On that box.
What? All right. 2x squared and 5. Two things that multiply to 10x squared but add to negative 9x with the same sign. Same sign.
Negative.
Uh-oh, speed racers. What's wrong? It's not factorable. Do we all see that? The signs have got to be the same because this is a plus. 2 times 5 is 10, but 2 plus 5 is 7. 10 times 1 is 10, but 10 plus 1 is 11. If this second sign was a minus, I could factor it. But it's not. So did we all agree that this is factored completely as I can factor it? Okay? Then my next step, once it's factored completely, is to set each piece equal to 0 and solve. Uh-oh, you may say. 3x squared is easy to set equal to 0 and solve, yes?
Yeah.
Because x equals what? 0. Thank you. But here's where it gets fun. How do I solve a quadratic that is equal to 0 that will not factor?
You have to make the other big C.
I could do that. That is definitely an option. But because she's talking about completing the square. But here's why I don't want to complete the square. And you most certainly may do that if you want. I can't complete the square with a leading coefficient, right? So I have to divide everything by 2.
Oh, decimals?
So then I'm going to start getting into 9 over 2 and 5 over 2. That's going to get a little hairy. What's another option for solving that quadratic? Say that one more time. Well, you can't, then it still wouldn't set you up to setting each piece. If you moved the 5 and took an x out, it still wouldn't be good. Somebody said it, who just told me? Did you say it? Tell them again.
Quadratic Formula.
Always works. Always works. It's set up perfectly for quadratic formula.
What is that? I mean, what is that?
You did not just say that. The song you made up?
No.
Okay. Actually, it's still on the board from, well, that's not Iris. So, this would be nice if it factored. No, it does not factor. You see how I was talking about we always go back and pull the things we learned from chapter 1? Now we've got a quadratic equal to 0. We're going to have to use the quadratic formula. Opposite B, which is what? 9 plus or minus square root of B squared.
Wait, what'd you do with
I ain't never saw this formula.
What I do with what? Oh my goodness, let me pause this video. 4AC all over 2A. What you confused about?
What'd you do with the 3x squared?
Why do what?
What'd you do?
Opposite B,
The 3x squared is going to be...
squared of B squared.
No, he meant the opposite.
Oh, that was a piece. I set it equal to 0 and solved it.
So that's out of it.
That's an answer on its own. I don't have to do anything else with it right now.
Yellow board.
9 plus or minus. 81 minus 40 is 41. I don't think you can divide 41 by any perfect square, can you?
Yeah.
So there we go. How many answers did we get? How many answers did we get? 3. Quadratic formula, when there's a positive number under that radical, gives us 2 answers. This is 9 plus square root of 41 divided by 4, and 9 minus square root of 41 divided by 4. Right? You don't have to work it out. You can leave it just like that. What do y'all think? The difference in factoring and factoring is we're just setting each piece to 0 once we get it back. Will they all be that hard? No, they're not all going to take you right up to the quadratic formula, but in this case, it did. So if this had factored, it would have been really, really nice because I would have just set each piece to 0 and solved from there. You want another example?
Yeah.
Yeah. I heard I'm fine with it, I'm good, and then a yeah. Let's do one more. Let's do a good one. What's whack, Moo Moo?
He said that. How you got our voice mixed up?
I don't know.
You sound nothing alike.
Cause you just always talking, Shani.
Yeah, I'm always talking about the decimal.
What do I need to do first?
Bring 14x.
Bring 14x to the third over. Now, whenever it is going to be negative, and whenever I do this, I'm going to keep it in standard form because it makes my life easier. Are we all in agreement there?
No.
No, where'd I lose you?
Oh, we just minus it.
I just subtracted that 14x. And I put it in the middle because I put it in standard form. Look at it. Look at it closely. First step of factoring is always to check for a GCF. Does it have one?
Yes. 2.
Good job. 2 what? What's left?
A to the 4 minus 7x to the 2nd.
Tanner, you on a roll. Factor completely. Can I factor that?
We don't know yet.
Put it in the box.
I can put it in the box. Why can I put it in the box? It's not a quadratic. It's what? It's in quadratic form, absolutely. It may not be a quadratic, but it's got that form. It's an even exponent, half that first exponent, and a constant.
Oh, we got to have that so you get a flat.
Quadratic form is the first one's even, the middle one is half of the first one, and then the last one is a constant.
What if you don't got that though?
Then you can't put it in the box. You can't factor it like that.
This is impossible.
No way! What multiplies to x to the 4th, 12x to the 4th, but adds to 7x squared?
Not negative.
Same signs, so you don't have to worry about signs. They're both going to be minus at the end.
Huh?
3 and 4.
3 and 4.
What do you mean?
Look at the second sign.
Yeah.
If it's a plus, they're both going to be negative anyway. The only time you have mixed signs is when that second sign is a minus. Remember?
But it's mixed signs.
You start with mixed signs, but you end up with same signs because the second sign here tells me that the signs are going to be the same. When it's a plus. Up and over. GCF.
A squared.
This is setting up nicely for another special pattern. GCF?
4.
4.
4.
X squared.
GCF?
3.
All right. Both of my signs are subtraction, yes?
Uh-huh.
So now I have 2x. X squared minus 4. X squared, minus 3.
A squared minus 4.
Is it factored completely?
Nope.
Why?
If that
Because
4
the
is.
first one, X squared minus
Y'all are so smart.
I know, right?
X minus 2 or X.
This is a difference of 2 squares. X minus 2, X plus 2. How about that one?
No.
No. Is it now factored completely? So now I'm ready to take each piece and do what?
Set
So them
Set them equal to 0.
That'll be
What's wrong?
that'll be good.
Yes, that'll be good. That's easy. 2x equals 0. X minus 2 equals 0. X plus 2 equals 0. X squared minus 3. All of these are pretty straightforward except the last one. The first one you get x equals what?
Yeah.
0. Second one?
Plus x
Third one?
x
The fourth one.
Move over 3,
Move over 3,
and then you're going to have to square root.
and you're going to have to square root.
So it's just going to be square root.
3.
What? It's just going to be what?
Oh, yeah, it's just
How about plus or minus the square root of 3?
yes.
That gives me 2 solutions. How many solutions do I have for this problem?
5.
Wow.
Well, that don't make no sense.
Look up at the top. Notice something. Look at what I originally started with. That's a hint of things to come. Look back at the other one. What was the biggest exponent on that one?
3.
We had a repeated solution there. I'm not going to use that as a first example. All right, questions? Comments? Everybody feel good about it? Good.